All right, I'm going to talk through the lab for you. This is a criterion B and C formative. Your last one was just a B, so you're going to add on to that C portion. For your pre-lab, you're just doing the B things. The only things that you did like on your Monstera lab, you're doing the same thing. So you're going to be exploring if a chemical reaction affects how much mass the substance has. So you're going to be taking the mass of something at the beginning, taking the mass of it at the end to see if the mass changes, or in the result of making a chemical reaction, the mass stays the same. You'll be combining 5 milliliters of water, 2.2 grams of calcium chloride, and 2.2 grams of sodium bicarbonate, which is baking soda, in a bag. So you'll mix together the powders first. You'll put 4 drops of phenol red indicator into the water, and then you'll combine both the powders and the water together and seal the bag. The indicator is something that tests like the pH of something, and the pH is like, how acidic or basic something is. It's just like you can explain what something is based on its pH. And it starts as red, and it's called phenol red indicator. That's something that you should look up in your background information to like, what is that? What does it do? Why do we use it? Where do we use it? That could be all in your background information. So you'll have 5 milliliters of water. You'll put the 4 drops of phenol red in. You will combine the water and the powders, the calcium chloride and sodium bicarbonate, into a bag, and then seal the bag. When all these are added to the plastic baggie, a chemical reaction is going to happen. You want to make sure to put in your procedure to seal the bag quickly, because otherwise you don't want anything to escape the bag. Your job is to prove the law of conservation of mass. Does it change mass from the beginning to the end? Make sure you add the mass of the plastic baggie before you add the steps. So you're going to have to take some data before the reaction and then take data after the reaction, so you kind of know the mass before and the mass after. In your background information, you should include conservation of mass, research on the chemicals you're using. You could look them up: calcium chloride, sodium bicarbonate. What do we use them for? Research on the phenol red indicator. What does it do? Problem statement, make it more general about like, why would people need to know about the law of conservation of mass? And you can kind of make this up, but like, people need to know about the conservation of mass because. So you fill in that because portion. You could put the people need to know. Why would it be important to understand the conservation of mass? Research question: how does blank affect blank? And then you're making a hypothesis that like is going to like make a guess. Like, do you think the mass will be the same at the end, or do you think it'll be different at the end? And why do you think that? Remember, if you're going for 7-8, you're using scientific language and correct scientific language. Independent variable, what are you changing? Dependent variable, how are you going to change it? Measured variable. You don't have a really concrete independent variable. Your question should be something about like, how does a chemical reaction affect mass, or how much mass something has? So your independent variable is probably going to be something like a chemical reaction, and you're going to only do one chemical reaction, but you could do more. So I would say your chemical reaction is your independent variable. That one's a little confusing. Dependent variable, what are you changing, or what are you measuring at the end? What are some of your controls that we should keep the same? If you were doing multiple trials of this, what would you want to make sure that you keep the same? What equipment will you need to run this experiment? Write your procedure. I already made a data table for you. You should make a data table that is an observational data. So like, what do you see happening? And that is an evidence of chemical reaction. So you're going to see a bunch of things happen. You're going to feel a bunch of things happen. When this happens, how do you know that it's actually a chemical reaction or not? And then that's where you're going to stop. After that, we will actually do the lab, and then you will do all your data. So where it says stop here, go ahead and stop here. That's going to be very important for you, because you can't do the graph or anything because you don't actually have any data. So reminder, when you are taking the mass of things before, or when you're writing your procedure, make sure that you have that you're taking the mass of things. So here it says reactants and products. You should add the calcium chloride, the sodium bicarbonate, the water, and the plastic baggie. Okay. All of those things you need all of those things to actually be a part of the mass when you are taking them, because otherwise you'll have the wrong mass. And then products, you can't separate everything else out because it should be a different thing, but you want to take the mass of everything at the end and compare the masses. So that's an overview of the lab. Good luck writing. If you have questions, you can wait until I get back or come up and ask me if you're my B-Day. This needs to be done before you are able to do your lab on Wednesday or Thursday, so make sure that you get this done all the way up into the data collection, because you need a data table to put your data in when you're doing the lab. Great. Good luck.